bottom-up parsers. The first parser is simple LR. Okay, so this is SLR. It can have two variants. One is LR0 parsing table, and it can have LR1 parsing table. So this is also called as SLR1. Okay.
Yes, ma'am.
Second one is CLR. Okay, this is canonical LR. It doesn't have any other variations. It is only CLR1. The moment it says CLR, it is CLR1 only. And there is no other confusions. LALR1. That's it. So this can be written as SLR sometimes. So they have to mention whether LR1 parsing table. If they mention SLR1, go with the LR1 parsing table, wherein you use the reductions only for, you will write the reductions only for look ahead terminals. Okay, for the reducing item. In SLR, LR0, you will have to write the reductions under all the terminals in that particular state. That is the difference.
So here LR1 reduction for lookaheids implies it's under the follow set only, right?
Yes, yes. Only for the look aheads, or you can say follow sets, yeah. In that particular state. Okay. Only three things. Don't get confused.
But for LR0 we construct an LR1 table, right, ma'am?
No. That is if they mention SLR1. If they mention SLR1. If they mention SLR0, then it's a LR0 parsing table then.
Ma'am, LR0 parsing table.
Give all these SLR1 only, not just SLR. If they have
Okay, ma'am, an example for LR0 parsing table.
For example, give me a grammar, no?
Ma'am, but before that, yesterday in that quiz you had given, there was a question if SLR1 is a stronger compiler than LR1. Actually, both are same rate in that case.
No. CLR is also called as LR1.
Okay. Okay, ma'am.
I forget that. Yeah. LR1, yes. So in your exercise problems, no, in the book, they have mentioned SLR1 only. LR1, did I mention anywhere? I'm just checking whether. See, LR1 items means it is CLR's item only with the look aheads. Remember that. Okay. I'm just checking what are the conventions they have used for.
So, ma'am, like SLR1, CLR1, and LR1, are they all similar?
No. Why? SLR1 uses LR0 automata and
Okay, my bad.
LR0 items. CLR1 and LR1 uses LR1 automata and LR1 items. Okay. Parsing table, this is CLR1 parsing table or LR1 parsing table. And this CLR1 means this is LR1 parsing table. Okay, it is, if they haven't specified this one, then you can consider this as 0, LR0, CLR0. They have to specify this as 1. Okay, if it doesn't do it in the question, then you can consider is not given about the look aheads. We are constructing LR0 parsing table. So if it is simply given as SLR, then it is LR0 parsing table. Because the automata is same for both SLR1 or SLR. Automata is LR0 automata only. The construction of parsing table differs. Okay, so if they haven't specified this one, then it is LR0 parsing table. If they have specified this as 1, that means it is one look ahead. Look ahead, how it is taken? It is taken by constructing the follow set. Okay. Any other confusion? LL1 is what?
Top-down parser.
Top-down parser it is. And this is also called as?
Non-recursive predictive.
predictive parser or non-recursive predictive parser.
I'm still, ma'am, like I am confused on that LR0 parsing table.
See, if they just mention, check whether it is SLR or not, then you have to construct LR0 parsing table. If
How
they
do
say
I do that, ma'am?
SLR1, LR0,
Like how to construct
I will tell you.
LR0 parsing table, that I don't know.
I've written this down, no?
Yes, ma'am.
Ah, okay.
Ma'am, also one doubt, ma'am. Like, see over here in CLR also we call it LR1 parsing table. In
Yes,
SLR also we call it LR1 parsing
yes,
table.
yes.
Like,
They are not different.
CLR makes use of LR1 automata, right? So should it be LR2 parsing table or something?
No, no, no. Two means two symbols look ahead are you doing? Follow set will
No,
give you
ma'am.
only one look ahead, na?
Yes, ma'am.
The only difference between LR1 of simple LR parsing table and CLR is how the items are written. In simple LR, we don't write the items with the look ahead in the automata. In CLR, we do that, right? How do you write the reductions in CLR parsing table? It is using those look aheads, right? Reducing item, whatever the look aheads are there, we are writing the reduction of that particular reducing item under those terminals. But in simple LR, what do? You don't have a look ahead in the item. So you have to take the follow set of the head of that reducing item and you are writing the reductions under that. Only that difference is there. But it is one look ahead only, no?
Yes, ma'am.
So give me a grammar, no? Simple one. I will take...
I will take yesterday's only, the one which was there in quiz. I'll tell.
that will give me a lot of states. I will take this.
Okay, okay.
Okay, so what do? For both simple LR, SLR and LR, CLR, you have the same method to be followed in the beginning. So you augment this grammar, right? S gives dot 0s1, S gives dot 01. Okay, this is simple LR0 automata I'm constructing. Okay, this is state number 0. So I get S dash gives S dot, right? This is 1 on 0. I have to take 0 dot S1 and also S gives 0 dot 1, right? Because of this S, I'm writing 0 S1 and S gives dot 0 1. Okay, then here there are no, because I have already taken this and this on 0, right? So there is no go to from this. Here on S, you have S gives 0 S dot 1. Any other? No. On S, it is 3, right? On 1, on 1 it is S gives 0 1 dot. Then on 0, it is the same state, right? So if you move the dot here, you get the first element, and also you move the dot, you get a first item here. Okay, so basically I will get the same items of this particular state. And on 1, it is S gives 0 S1 dot. This is state number 5. Okay, this is LR0 automata. Now we will construct both LR0 parsing table and also LR1 parsing table. Okay, so LR0 parsing table, how do you do? Okay, you have the states, action, and go to. So 0, 1, 2, 3, 4, 5. Okay, and for the actions, I will just write here 0, 1, and dollar. This is the actions. And for go to what you have S. Now, shifts you know how to write. From 0, 0 on, S it is 1, and 0 on, small 0. I mean, the 0, this one is S2, shift to 2. Then 1, I don't have anything. 2, I have a shift on 1, that is 2 S4. On S, it is 3, right? From 3, You have a shift on 1 to S5, right? That's it. For the shifts are concerned. Now, how do you write the reductions?
1-0 goes to S2 itself.
S2. Yeah. So to write the reductions, what do? You number the grammars, right? So productions and the grammar. So it is, if you take, this is 0, 1, and 2. Take the last item, see in which state you have it, fully seen. It is state number
4.
4. State number 4. So how do you write the reductions? How do you write the reductions?
We put it in the follow set.
Follow of S is $1.
So,
So
ma'am, but
if
it
you
will be similar to.
no. Wait. If I do it, if I write the reduction R2 under 1 and $, it becomes a LR1 parsing table because I'm using the follow set. Follow set will give me one look ahead always. Okay. So now I'm constructing LR of 0 parsing table. So on the state number 4, where I have the reducing item under, it doesn't see because LR0, right? It doesn't have a look ahead. So what it does, it writes under all the terminals the reduction. Okay. That is the main difference between LR1 parsing table and LR0 parsing table. So on that state, under all the terminals, it will write reductions because it doesn't know the look aheads.
So then the chances of shift reduce conflict are more.
Yes, that's why it constructs our LR1 parsing table. That's why we go for LR1.
Yes, ma'am.
Okay, so state number 5, we see the this reducing item, state number 5. So you will write R1, R1, and R1. It doesn't see anywhere. Okay, and also on state number 1, it is R0, R0, and R0. You don't have a, explicitly accept. It is not only under dollar because you don't know under which it will stop. Okay, that's why what we do, we don't use the LR0 parsing table, we go for a LR1 parsing table. Wherein, what is the difference? The difference of LR1 parsing table is for state number 5 only for the look heads of the head of the production, that is $1. $1, we are writing the reductions. Okay, at state number 4 also we are writing only under 1 and $, and in state number 1 we write except here instead of R0. Okay, because here we explicitly know under which it stops, the parsing should stop. This is what is LR1 parsing table. So if they simply mention SLR, it is LR0 parsing table. If they mention SLR1, it is LR1 parsing table. But the same thing if you construct using the CLR. Okay, what do? You write the look ahead in front of each of the items, right? So for this, whatever the look aheads you write, under that you will write the reductions in the parsing table. But it is follow set only. You can cross verify using the same construct, the CLR, LR1 automata. So this LR1 items, you construct that and construct the CLR parsing table. Just see, you should get 1 and $. Yeah, here this will not come because if you on 0, if you move, the look ahead will be 1, so it's a different item. So you have to construct a different state on 0. Scale 0.1, scales 0 1 is gives dot 0 1. So for this, the look ahead is 1.
One for all.
Yeah,
One for all, and then there will be a loop for 0.
here.
Yes,
Yes,
ma'am.
ma'am.
And also on this one, it will change, no? On S.
One.
Yeah. So you'll get more states than SLR. So what happens? No, you will get $1 for state number 4, 4 and 5. Instead of that, you will have a split. In one state, you will get the reduction R2 under 1 and the reduction R2 under dollar in another state. That is what's going to happen. So you will have 2 or 3 more states. Wherever you have $1, no, that will get split up. So 2 and 2, 4 more states you will get. Are you getting 4 more states?
Yes, ma'am. Ma'am, how many marks will a question come for if we have to draw the automata as well as the table? Like we have to do both, obviously.
8, 8, 8.
Yes, ma'am.
Yeah. Minimum is 8. If at all, if you have to pass the string also, should be for 10.
Also, ma'am, can we do one more backpatching problem because I needed a practice on that. Just one problem we did.
Ma'am, before that, the lookup for state 4 is dollar, right?
Which one?
For state number 4 in this question.
State number 4. 0.
0, 1,
Yeah,
2.
yeah. This is dollar.
Okay.
Backpatching, we have to take a different expression. Give me an expression, no? Okay, let us replace the or with the and with the or.
Ma'am, is it possible if we can get backpatching questions with if else statement, like flow control statements?
That is rarely done because to do that you have to do Boolean expressions backpatching also. Then only you can complete the flow of control statements. No, so
Yes,
we are for minimum 10 marks. I don't think because you have many other things in intermediate code. Only that one will not be given for 10 marks. If I am the setter, I will not give.
So for backpatching, only Boolean expression would be enough.
Huh. Boolean expression, either this or that. If I go with the flow of control, it will be a 10-mark question. If I go with the Boolean expression, it will be a 5 to 6 marks question.
Okay.
Usually, the translation statements schemes will be asked for flow of control statements, and expression is asked for the Boolean expression backpatching example. Usually.
Okay, ma'am.
Anyone will give me a Boolean expression to write?
X greater than 20 and y greater than 10 or x greater than 30.
Okay. First, you have to write the syntax tree. How will you write the syntax tree? First, I will mark the sorry. So it goes like this, right? So you have this. Now this is the next one, and then what? And this one. Is it right?
Yes, ma'am.
So using the grammar, you just draw the tree first. So what is the first tree? Which operator will come here? And or?
Or ma'am. Or.
M, B, and again this B.
B and
The first one B will give and.
M, B, and this B should give
Relational
X.
operator.
Yeah, I just write because it doesn't change anything, right? So X greater than 30. Here it is X greater than 20, and this is Y greater than 10, and this is epsilon. This is epsilon. Okay. Now have your STT translation schemes with you. For first, what it will do? It will start from B, right? So when it is coming here, what will happen? Who's this one will execute it first? Which list is getting created first?
For the relational operator.
This one, right? So you get B dot T and B dot F. B dot T is with
B dot F is 101.
next. So once it is created, you have an AND. Okay. So in that case, you have to check the true list also, no? So true of this one, the true list is created. So 102, and B dot false is 103. Okay. Now, what will happen with M dot I? You're backpatching on
B dot true.
True list.
yes, true list. So it will be index of the true list.
Yes.
Okay, 102. So now at this B dot T and B dot false. What is B dot T for B and
B dot T
T1?
will be 102 itself, and B dot false will be merge of both. False.
Merge of both. So it is 101, comma 103. Okay, clear? So you come here and this is M dot I. To create this, I have to create B dot true and B dot false. What is the next index? 103 we have stopped. So this will be 104. This is 105. Now you tell me M should have whose index?
105.
False.
Okay.
Or should have?
It should have the true one. Ma'am, 102, I guess.
Hey, 102 is done. M should have the index of what? B, B1 or MB2. So M is you are backpatching M instruction with
B1 dot false.
B1 dot false. 105. No, wait. Otherwise, we'll miss out 104, no? If we directly go to 105. M gives epsilon as M instruction, and it is just the next instruction. Backpatch we haven't called yet. So backpatch is called only when B or B is getting reduced to B. So this should have the next instruction, that is the index of the next instruction to be executed. So this will be 104 only.
Okay.
How it is
All it will be the next true list address.
true list, yes. Because if I directly go to false list, I will miss out the true list, right? So I cannot do that.
So this is before backpatching. While backpatching,
Yes.
the false list.
Backpatching, you just see, for M gives epsilon, I don't have a backpatching which is getting called in the translation scheme. It is for either B, B1 or B2. B gives B and B2. Only then we have a backpatching getting called. Otherwise, we don't have a backpatching getting called.
Ma'am, could you repeat what you just said?
For M.I, it is always the true list, the index of the true list of the next relational expression. Okay, for B, the true list index it will have always. Here also, because if you see the STD, which I have given for translation schemes, which I have given for Boolean expression, what is there for M gives epsilon? It is M dot instruction is equal to next instruction. That's it. There is no backpatching getting called. Backpatching is called only when B or B is getting reduced to B, or B and B is getting reduced to B, right? Otherwise, it is not getting called. So M.I will always have the index of the true list of the next relational or a B, next B which is coming up. Okay. So if you have B or MB, B1 or MB2, it will have M will have B2's true list index to be there in M.I. Okay, always you remember this. Okay. So
Yes, ma'am.
now B dot T T and B dot F. C, B or B, B1 or MB2, you are backpatching. B1's false list, comma, im instruction. The true list is merge of B1 true list, comma, B2 true list. So B1 true list and B2 true list is 102, comma, 104. What is B dot false? It is?
B2 dot false.
It is 105. So backpatching is especially required when you're writing the if in the 3 address code way. So if you have to write in the 3 address code way, how will you write? Try writing that. We have written at 100 and 101. So at 100, I created the true list for this. So if x greater than 20, okay, go to the emit will happen. If you see B gives even relational operator E2, true list is created 100, B dot false list 100 plus 1. Emit if x greater than 20, go to dash, and at the false case, you will have go to dash. Right, that is what is getting created. At 102, what you have created? You have created the true list and the false list. So it will be if y greater than 10, go to dash, and at 103 it is go to dash. Okay, then at 104 you have this expression. If x greater than 30, go to dash, and 105 you have go to dash. Now, when it is getting reduced at this B, you are backpatching what? B and MB2. B1 and MB2, you are backpatching B1 true list, B1 true list with M instruction. What is M instruction? It is 102. B1 true list, you are backpatching. Okay. So is it right? If x greater than 20, go to dash, and if B1's, sorry. Okay, backpatching is on B1's true list. This is B1's, this is B1, right? This is B2. B1's true list with M instruction. M instruction is 102. Okay, B1's true list is 100. At 100, I'm backpatching the index 102. That means if x greater than 20, then you have to jump to 102 and check this also, right? Because it's an AND. You have to check both the trueness. Okay. Now here in B1 or MB2, what is the backpatching which is getting called? Backpatch on B1 false list. B1 false list is 101 here. And also you have a merge, right? So 103. Both are B1's false list. The B1 false list with M instruction, 104. Check whether it is correct or wrong. So what it is telling?
The 104 is backpatching.
104, when it's getting reduced, B1 or MB2 is getting reduced, B, backpatching is called. So 104 is backpatched on B1's false list. We have a merge, 101 or 103. That means, see, if x greater than 20, that is not true. Okay, if it is false, then you are jumping onto 104. That is correct. So if this is false, then you have to check for this, right? So in which case this will be false again. Here I have an AND. This can be false or this can be false. That's why there is a merge. So 101 can be false or 103 can also be false. Two things are there. So both the cases, it will become false. So it should go to 104. If x greater than 20 is true, then it will jump to 102. Okay, there it will check y greater than 10. Go to, we don't know the true list here. Backpatching is applied on the false list. Okay, if this turns out to be false, then the B1 is also false. So what is it should do next? It should go to 104.
Yes, ma'am.
Only this much you can do with the Boolean expression backpatching. Rest everything is taken care by flow of control statements, the label generation and backpatching. There also it is applied, right? So it will be taken care by in the level up. Here we are backpatching only 102 and 104.
So the rest will be left.
For the flow of control statements, I told you, no, it has to do one more pass. Flow of control statements. There also we have label generation and translation schemes, right? And we do go to emit and all those things. That higher up is not required. Only Boolean expression they'll ask you, not more than this.
No, ma'am, like over here also some Boolean expression is left out, right?
No, that's what. This will be filled by, because this is the part of, this will be like this, no? If something and then you will write something 0. So flow of control statements for if S, that you have to check for backpatching. It will start from there. If B, then it is S. So we have done for this B now. And for this flow of control statement also you have what? If B M S1, you have a backpatch on B true list with M instruction. Right, so that will be taken care of there. The other statements.
So in exam we just have to write down till here and then write down the rest will be backpatched by flow of control statements.
Yes.
Okay, ma'am.
On the theory part, we should just explain how we got it, right? So we write the tree, we write the instruction list, and then.
And you have to write this translation scheme for Boolean expressions. How we have called merge, backpatch. What is merge? What is backpatch?
Oh, okay. Yes.
So only
Okay.
B1, B2 as well as B1 or B2. Only those two it's sufficient, right? The translation scheme.
But you need E1 relational operator E2, B false, and M giving epsilon. You can only skip not and it's
Yes.
okay.
So like we have to write down the rules which we wrote down, like backpatch of this B dot rule list.